Hello everybody. Today we're going to be going over trigonometric substitution in Calculus 2. Now, this is a method to solve complex integrals by simply making a trigonometric substitution. Let's go over some rules first. So, for integrals in the form integral of the square root of a constant squared minus x squared, we're going to use the substitution x equals a sine theta. For the integral of the square root of a squared plus x squared, we're going to have x equals a tan theta. And lastly, for the square root of x squared minus a squared, we're going to use x equals secant theta. All right. We'll start off with an example, and I'll show you how to walk through the steps. So, imagine we have, let's say, 4 minus x squared. We have this integral. How would we solve this? Well, we have a square root and we have two terms under it. We can't really split anything, so we're going to have to dig into the bag of our trig substitution. So we can see here that we have a number, and then we're subtracting an x squared. So it's looking like it's going to be this form right here, the first one, where we substitute a sine of theta. So what this looks like is the square root of 2 squared minus x squared. Okay, and what this gives us is our a value for substitution. So what we're going to do to make our substitution, we're going to let x equal our a value, 2 times sine theta, and our dx value, just like u substitution, we're going to calculate our dx value, is going to be 2 cosine theta d theta. And then we just move everything over. We get d theta equals I guess we can secant theta over 2 dx. Okay, hold on a moment. Actually, I didn't need to do that. Don't worry about that. Dx equals that. Okay, so now what we're going to do is simply rewrite this integral as the square root of 4 minus, remember, x is equal to 2 sine theta squared, and then times secant theta. We could put the 1/2 on the outside, and then we'll have d theta. All right. So now let's simplify the things inside the square root. So we'll have 1/2 the integral of the square root of 4 minus 4 sine squared theta. So, in other words, what we can easily do here, and the main idea, is that we set it up as the a value to be 2, because when we square it, we get a common factor of 4, so we can factor out 4. So we get 1/2 integral of square root of 4 times 1 minus sine squared theta, and then times secant theta d theta. Okay, so now we're having terms multiplied. If you remember from your trig identities, this is cosine squared at, or theta in this case. So it lines up perfectly to be that we have the square root of 4 cosine squared theta. And we actually can easily take the square root of this. Super simple stuff. So this will be equal to 1/2 the integral of 2 cosine theta times secant theta d theta. And luckily, the secant and the cosine cancel out because they're reciprocals of each other. And then we're left with 1/2 the integral of 2. 1/2 the integral of 2 d theta. So we can now simply just integrate. So this is going to be 1/2 times 2 theta. And so this is going to equal theta. Now, all we need to do is get our x, because we're asked the integral of the square root of 4 minus x squared, so we need to bring it back to the x world. So remember that x is equal to 2 sine theta. Let's just solve for theta. So first, you probably want to divide by 2. You get x over 2 is equal to sine theta. And then you can take the inverse sine on both sides. So then you get the answer as arc sine of x over 2. And you can't forget to add the cheese. The substitution we're doing is going to be on the denominator. So you will see eventually how this is going to, how this is going to change how things go. So for this substitution, we want to make a tangent substitution, because that's the one that we do for a squared plus x squared. And so we'll do the substitution, let x equal, what's our a value? Well, our a value is usually the square root of the number. So in this case, the square root of 6 tangent theta. Okay, and then now, as our normal use substitution, we do dx is equal to the derivative of tangent is secant squared theta. And then we can't forget to tag along the square root of x, or the square root of 6. So now we transform our expression into the integral of 1 over the square root of 6 plus the square root of 6. Square root of 6 secant not secant, I meant tangent theta squared. Now we have to add our dx, so we'll have times the square root of 6 secant squared theta d theta. And then now let's just simply move the constant to the back end. So we'll have the square root of 6 times the integral of 1 over, we have to, square root of 6 x squared is 6 tangent. So we're going to have the square root of 6 plus 6 tangent theta, tangent squared. So this is going to be 6 times 1 plus tan squared theta, all under square root, d theta, And actually, can't forget our secant squared. We're going to put the secant theta. Okay, now we just get the expression root 6 times 1 over the square root of 6 times, we have 1 plus tangent squared, and 1 plus tangent squared is equal to secant squared. So secant squared secant squared under square root is just times secant theta. And then we'll have times secant theta, and then d theta. Okay, so luckily, our secants are actually going to cancel, and we're going to be left with 1 over square root of 6. We're going to be left with the square root of 6 times the integral of 1 over square root of 6. And now we can just multiply everything in. So we get, this is equal to, the root 6 and the root 6 are going to cancel. And we're going to be left with the integral of d theta, which is just theta. Now, from our substitution earlier, if you remember, we said x was equal to root 6 tan theta. So all we have to do is divide by root 6 and then take arctangent, and then we get our theta. So our final answer will be, this is equal to arctan of x over root 6, and you can't forget to add the cheese. So this is the answer for this problem. I hope you liked this video, and I'll be continuing to make more calculus 2, 3, 1, and also some beginner level maths videos in the future. Anyways, leave some suggestions in the comments, and goodbye.